Hello, everyone. We're at the end of week 11. Today's going to be kind of a short day. We're going to finish up, we're going to introduce while loops, which is another way of iterating through computation. On Monday, we did for loops. For loops was a way of iterating through a finite sequence. Sometimes we might have infinite sequences. So for loops aren't really meant for infinite stuff. Right? That's where while loops come into play. While loops are good for possibly infinite sequences. There's no lab associated with this. There's only a lesson. Right? So it's going to be a pretty short lesson. And since it's short, we're going to take a sneak peek into next week's content. But next week is going to be about looping algorithms. Right? These are all actually going to be on for loops. So yeah, we're going to finish up while loops and then jump back to for loops and apply some algorithms. But we need to take a sneak peek into next week because next week is going to be pretty dense, actually. It's going to be pretty dense. So we're going to have to talk about this today instead of next week. All right, so let's jump into the while loops, right? There's only a lesson associated with it, but no lab. So I have it loaded up here already. Here, let me load it up again. Close, close. It's right here, lesson number 16. That's pretty much it. You know what? I'm not even gonna go into this notebook yet. I'm gonna kind of deviate away into a different environment. And the reason why is because I don't really want to bloat my output with a bunch of statements. You'll see this in a bit. So here, I'm gonna switch to a different Python environment. It's more of a classic one, right? Not a Jupyter one. So for folks who have VS Code, you can use that. I'm just gonna stick with the pure terminal. See. Let me just change directory real quick. Okay, I'm just gonna change directory. I'm just going into a folder called examples. All right, let me make a Python file. Right, I'm gonna make a Python file. I'll call it while loops .py. Okay, there we go. So all I really did was I used a text editor to create a file called while loops. I'm using Vim. You don't have to use Vim to edit text. Once again, most folks start off with VS Code. So yeah, you can use that as well. And anyways, uh, let's say we had a number. Right, so I'm just going to say number is equal to a 0. Right, once again, this is like Python right here, right? We're setting a integer equal to 0. I'm just going to introduce the while loop right away. Right, so the while loop, the control flow is a little different from the for loop. Right? It pretty much starts off with while some condition. Right, so while some condition, I'm just going to hard code a true for now. Right, hard code a true. Right, this means that this condition is always true. It's kind of like an if. It's like saying if some condition, then do something. Right? The only difference with the while loop is that it's going to loop up to the condition and keep checking it. Right? So here, I'm just going to program an infinite while loop that prints the number. Right? So I'm just going to print the number and then just increment it within every iteration. Right? So this is saying number equals 0. Right? We're going to go down a while loop. Right? So imagine this is an if statement. Right? If true, right? Is this condition true? Yeah, it is true. I hard coded a true, so it's always going to be true. And we're just going to print out the number, increment it. Right? And here's where the loop comes into play. Right? At the end of the loop body, we're going to go up and check the condition again. Right? Is this condition true? Yes, it is true, right? Because I hard coded true. So it's going to execute the loop body again, and then loop up, check the condition again. Right? So it's kind of looping over and over again over the condition and the body. Okay, so here, let me play this file real quick. I'm going to load up another terminal and change directory into it. Oh, here, let me just reload this. Okay, there we go. So I'm just gonna press play on this file. Right, if you're working in a terminal, you can just do Python while loops.py. That'll run it. Right, and check it out. I'm gonna press play and kind of see what's happening. It's executing the while loop. Right, it's actually infinite. It's never gonna stop. Right, so the reason why I did this in the terminal is because I didn't want to bloat my output in the notebook. Right? It is possible to do this in a notebook as well, but then you might the kernel might act weird because the output will get very, very large. So yeah, you could try this in your notebook, but there's a chance that the notebook can't keep up and it might crash or something. So I'm just gonna stick with this classic one. Okay, anyways, hopefully people see that this is an infinite while loop, right? Because we hard-coded a true. What if we put a different condition in here, right? Like let me put a Boolean condition that tells number to keep going until it reaches 20. Right? So I could say while number is less than 20. Or here, look, let's make it like 30. It doesn't really matter. Right? So once again, the syntax of a while loop goes while some condition, right? If this condition is true, then we're going to execute the body and then go up again and check. Right? So this should execute like 30 times, right? Because here, let me cancel out of this program. So I'm just going to Control C out of it. There we go. Quit the program and let me rerun this. So I got to save this file and then rerun this. So here we go. I'll run it and there we go. See, it printed 30 numbers, right? 0 all the way to 29. Right? It doesn't print 30. I hope that makes sense why it didn't print 30, right? Because when it gets to 29, right, when number reaches 29, we're going to increment it to 30. Right? So number becomes 30, but then we're going to check, right? Is 30 less than 30? No, it's not. Right? So since it's not, we're going to terminate the loop. Right? We're going to exit the loop and go down here, right, outside of it. We're cool with this so far? Okay. So once again, almost every for loop can be written as a while loop, right? If we were to write this in a for loop, then it would just be for num in range of 30, then print num, right? So every for loop can be written in a while loop, right? These two are going to do the same exact thing. Right here, look, let me just print a bunch of the vertical line here of width 20. Okay, so let me just run this again. Right, so there we go. So this is the while loop, right? The while loop goes from 0 to 29, right? And the for loop does the same exact thing, right? All the way to 29. Right? So yeah, they're pretty much the same thing, right? Okay. Let's see. Let me do one more example and then switch back to this number thing, because I'm planning on writing some sort of guessing game. Right? You might remember we did a guessing game of a couple weeks ago. So we're gonna start looping that game. Right? But I just want folks to get comfortable with the while loop. Right? Like on Monday, we did for loops. Right? I think the first for loop we introduced was iterating through a sequence. Right? Like let's say we had a sequence. I'll call it animals. Right? Let's say I call it animals and just put like dog, cat, and then bear. Right? It doesn't matter. But we ended up writing a for loop that iterates through the sequence, right? Like for item in animals. Now, once again, animals is the sequence, and then item is a variable that represents each item, each element in the sequence. And then we ended up just printing the item. Right, so this is just going to print dog, cat, and bear. Right, so this can be written in a while loop as well. Right, every for loop can be refactored into a while loop. Right, it's actually more suitable to write it in a for loop because it's more readable. But one way we could write it in a while loop is by kind of keeping track of the indexes. Right, like we could say, hey, start a number at 0, and end it at the length. Right? The length here is 3. Right, so here let's say let me just print a vertical line, a horizontal line, I mean. Okay. An equivalent way of running this in a while loop is by keeping track of a number, right? So let's say I keep track of like I, or yeah, I here is going to be kind of like an index. I'm just going to say index. Now let's say I start index at 0. Right? This is like saying, hey, start at the 0th element. Right? And then we can increment I, or the index, up until the length. Right? So let's go ahead and write the while loop. Right? So while index, right, is less than the length of this animals. Right? The length of this animals is 3, right? Meaning that it's going to go 0, 1, and 2. And then when it hits 3, it's not going to hit it. All right, so length of animals. All right, once again, length of animals is 3. All right, so this while loop will happen 3 times, right? 0, 1, and 2. Okay, so here I'm just going to use that index, right, and print out the element at that list index. So let's go ahead and print it out. All right, so I'm going to go print out the item, right? The item is represented by the animals indexed at that list, right? Animals is a list. So when we put a number inside of these square brackets, it'll access that element. Right, so there we go. We're just going to print animals index. Right? And we do need to do one more thing, right? Because this is going to be an infinite while loop. Right? Do people see how this might be an infinite loop? Right here, let me run it. Okay, so if I were to run it in its current state, right, you see it's printing dog, dog, dog a bunch. Right, this is actually an infinite while loop, and it's not stopping. So I'm going to actually terminate this program real quick. I'm on the terminal. The terminate sequence is Control-C. So I'm just going to interrupt that. Right, hopefully people kind of see what's happening. Right, basically index is always 0. Right, so it's always printing the dog right here. Right, we need to increment index. Right. And that should give the loop condition a reason to stop. So I'm just going to go ahead and run this. There we go. Right, this second part is the while loop. Now people kind of seeing what's happening here. Index is a number, and we're using that number to index each individual element. All right. So yeah, hope folks are cool with this. This is kind of a sneak peek into while loops. Every for loop can be written as a while loop. Okay, here let's go back to a previous example. Right, let's go back to the numbers. Earlier we did a guessing game. Right, on a couple weeks ago in the logic and decisions, right, lesson 14. A couple weeks ago we did some guessing games here. Let me see where it is. Yeah, you can take a look at this. We pretty much did some guessing games where the user would have to type in a number, and then if they got the number wrong, then it would say, oh, too low, right? And it would say, oh, that's right. All right, let's do this again, but with a while loop instead. Okay, so let me clear all of this. Okay, let's say we were writing a guessing game where we generate a random number from 0 to 10, and we want the user to guess that number. So here, let me start by generating a random number from 0 to 10. So I'm going to store it in a variable called answer. Right, answer is equal to some random number. Right, so I'm going to actually import a library that allows us to generate random numbers. Import random. This is a library that lets us use a function called a randint, right, which is a random integer. And it takes some amount of arguments. Right? But basically, I'm just going to put in 0 to 10. Right? Well, what this does is it says, hey, generate a random number from 0 to 10. Now, you can look at the documentation for this. You can just Google up something called random int on Python, and then it'll show the documentation. Right over here, this is the primary source. Right, so let me just look for randint. Yeah, so random.randint is a class function that returns a number from A to B. Right, A to B is right here in the arguments. Okay, so let me just generate a random number. And you know what? Before I start asking the user to guess a number, let me just sanity check this variable. Right, sanity check means to kind of print the value of that variable. So answer is, so this is a sanity check. I just want to make sure it's generating a number correctly. So let me Python while loops. Okay, answer is 10. Let me run the program again. And there it is. It's 5. Let me run it one more time. 8. Okay, there it is. Oh, 8 again. 9. 1. Okay, cool. So all I did was press play on this program a bunch. And yeah, it looks like it's generating a number. Okay, so we just sanity checked this random number. Let's go ahead and make a loop that asks the user to guess until they get it correct. And this is a possibly infinite loop. Right? While loops are good for possibly infinite sequences. Right? In this case, the sequence is the user is guessing over and over again. So we need some sort of variable to store the user's input. Right, I'm going to initialize a variable called guess equal to -1. This way we can, the reason why I started it to -1 is so we can initiate this while loop. Right? The while loop, the condition should represent while they got it incorrect. Right? While they guessed wrong, then we're going to ask them to keep guessing. So we could represent that condition by saying their guess is not equal to answer. So this is saying while they got it incorrect. Right. Hold up, my projectors are flickering. Give me 1 second. Sorry about that, George. Oh yeah, you can join in on Zoom if you want. Let's see. Here, you know what? Let me restart these projectors real quick. Okay. So once again, this condition is representing while they got it incorrect. All right, we initialize guess to -1, so we can iterate once, right? So -1 is never going to equal this, so the condition will be true on the first iteration. So then we can go ahead and prompt for input. Right? There is a function on Python called input. This is a native function. It pretty much does two things, right? It displays a prompt and then grabs input from the user. Right? In this case, the prompt, I'm just going to say, guess a number from 0 to 10. So this is a prompt. It's going to print it out, but it's also going to do another thing. Right? It's going to grab input. So I need to store this input into a variable. Right? In this case, I'm just going to store it in guess. Right? So guess is equal to whatever they typed in. Right? And real quick, we do have to convert this input into an integer because this input function returns a string. Right? So we can't really use a string. We have to convert it to an integer. So I'm going to use an integer right here. There we go. So all I did was I wrapped this input in an integer conversion. The reason why is so we can properly compare the numbers. Oh shoot! Yeah, that was. Okay, let's see. Okay, so let's go ahead and run it. Okay, so let me Python while loops. Okay, there we go. Okay, so there we go. I just ran it. Let's trace through this program. Right, we generated a random answer. Right? We initiated guess to -1, so we can enter the while loop at least once. Now we enter the while loop because this is true. Right, -1 is not equal to this number. Right? The number is 0 to 10. Right? It's not equal to that. So we're going to enter in the body of the loop, and then the input here, right, the right side is evaluated first. So the input function prompts the user, guess a number. Right? So it's waiting for input. Right? So we're stuck inside of this input function. Right? And once we type something in, like 5, right, I'm going to type 5, the input function will finish. Right? It'll finish and it'll evaluate to a string of what we typed in. Right? And then we'll convert that string into an integer and then store it into this variable guess. Right? So let's test it. So I'm going to press enter. Right? Enter, and there we go. Right? 5. 5 was incorrect. Right? 5 was incorrect. So we went up here. Right? It was incorrect. So now we're doing it again. So let me keep guessing. Like 6, 7. Okay, cool. Now 7 was the correct answer. Right? Basically, when we typed in 7, a guess became the integer 7. Right? And then this condition became false. Right? Since that condition became false, we terminated the while loop. Okay, so this loop is actually not that helpful right now. It might be useful to give hints to the user, right? Like you might remember we gave the user like, oh, you're too low or too high. So let's go ahead and do that, right? Basically, we can branch off into different scenarios. Like if their guess is too low, right? So guess is less than answer, then we can print too low. And then another hint, else if the guess is greater than answer, then print too high. And then finally, if these are false, then they probably got it right. So I'm just going to do the last branch as correct. Okay, so let me test it now. So Python while loops, enter. Okay, cool. So guess a number from 0 to 10. Let me guess 5. I press enter, and it says too low. All right, once again, that's because this one was true, right? Our guess 5 was less than the answer. So then we're going to loop back up. Right, this is still true because we didn't get it right yet. So let's guess another one. Let's go 7. All right, 7 is too low. Right, and then let's guess another one. Let's go 9. Too low. All right, okay, it must be 10 then. So let me guess 10, enter, and there we go. We got it correct. All right, the reason why the program terminated here is because when we typed in 10, right, none of these first 2 branches were true. Right, so we printed correct, and we loop back up to the condition. Right, is this true? Right, no, it's false. Right, it's false because 10, because we got it right. Right, 10 is equal to 10. So this is false. All right. People cool with this so far? People cool with this intro to for loops? I mean, while loops?
Yeah.
Okay. Oh yeah, someone asked about my environment here. Yeah, I pretty much have a text editor on the right, and then a terminal here on the left to kind of just visualize the output. Right, some folks might have a different environment, like a VS Code. So here, let me pull up a different environment, which doesn't require the internet. So some folks might have something called a Visual Studio Code. So let me just pull it up real quick. Yeah, and if you have this VS Code, then you can pretty much, open up a certain folder. Right, so I'm going to open up the folder where my Python stuff is. Let's see, my Python stuff is located here. Let me just quit all of these. These were from previous class. Okay, cool. I just opened up a folder. Right, so on the left, this is a file explorer. It's kind of like Jupyter Lab. We just wrote this file here called while loops. So yeah, it's the same exact thing. And the terminal here is on the bottom. Right? It's a similar environment. Right? Basically, you're editing text, and then in the terminal, we're viewing the output or the inputs and outputs. So I can go here, Python while loops.py, and then yeah, it's the same thing. So I can guess 5. 5 is too low, 7, too low, 9, and 9 is correct. Okay, cool stuff, right? You can do this in the Jupyter Notebook as well, but I decided to kind of deviate to a different one just because folks might be going on to a different class after this. Right? Folks might be going on to an intermediate Python class, and they're going to be using a non-Jupyter environment. Okay, hopefully people are cool with that while loops so far. So let me switch back to the lesson. Let's see. I'm gonna let the folks read through these lessons themselves. It's pretty much the same exact thing that we did earlier. So yeah, if you could take a look at it. We already did all of this, but in a different environment. So yeah, we're pretty much done with while loops. People cool with this so far? That we did this lesson in a different environment, and yeah, folks can look at this later.
Yeah, I was actually doing it out of Python or VS Code
Okay.
too.
Yeah, for this class, we're just mainly going to be using for loops because in the couple weeks later, we're going to be doing data analysis where we're going to be iterating through a finite sequence. Right? We're not really going to be doing too many things with while loops, but it's still useful stuff, right? Like, what if you were to write a blackjack simulator or some sort of gambling game, right? A lot of the students in my C++ class seem interested in that. So, you could program games with while loops, right? Like while some condition, let the player keep playing. It doesn't have to be a gambling game. It could be, an RPG game or anything else, right? Like while the player has a positive health, then let them keep playing. Okay. People cool with this so far? Good old while loops. Okay. Okay, cool. We're done with this lesson. All right, once again, it's a really short one on while loops. There's no lab associated with it, nor homework. All of our homework in the future will really just be doing for loops. Okay. Cool. Let's get ready for the loop algorithms. This is scheduled for next week, but once again, next week is going to be pretty dense. So let's introduce some loop algorithms. We're going to go back to for loops, by the way. Okay, so let's go ahead and load up a couple things. Maybe just the lesson 17. And here, let me look at the lab as well. Let me see how far we can get today. So I'm going to load up lesson 17 on algorithms. Let me see the lab as well. Okay, you know what? We might have enough to do at least the first 3 in the lab. So I'm going to switch back and forth a bunch. But we're really just going to touch the very top of this lesson, right? Lesson number 17 on loop algorithms. Right, well, we're just going to talk about something called reduction algorithms, which pretty much takes a sequence and then collapses them down to a single value. Right, that's all we're really going to do today. And then next week we'll jump into some more complex algorithms like filtering. Let's see, mapping. Right, you can take a look at this later. Okay, so let's go ahead and load up lesson 17 and lab 17. Okay, and then here, give me a few minutes. I'm gonna restart these projectors because they're kind of glitching. So let me pause the recording here. Good old loop algorithms. Looping algorithms are good for repeating some certain amount of steps to reach a solution. Right, so for now, we're just gonna do some really small computation. The first one we'll do is summing everything up in a list. Or like say we had a list of numbers and our goal was to write a loop that just sums it up. Now, this is useful for like statistics when we're maybe calculating the average. So yeah, the sum would be one of them. So let's go ahead and write this loop. Okay, I'm going to go ahead and declare a list of numbers. Right, like let's see. I'm just going to say numbers equal to sum list. So just say we had a bunch of numbers. I'm just going to reuse these numbers up here. 1, 23, all of this here. Okay, there we go. So I'm just going to declare a list called numbers. Let's say we wanted to write a loop that iterates through every single element and kind of just sums it up. Right, so we do need to write a for loop, right? A for loop is good for a finite sequence. Right? You can do this in a while loop as well, but it'll be a lot cleaner in a for loop. Right, so in this case, we're just going to write a for loop that takes a number. Right, so I'm going to say for number in numbers. And once again, one of them is singular and the other one is plural. Right, the sequence is plural, and this one is just number. Okay. So yeah, this variable number represents every single element in here. Okay, so let's go ahead and sum it up. Right, like for now, I can just print it out. Right? So let me just print it out just to make sure we're on the right track. So I'm just going to print it out, press play. There we go. So he's printing out every single number. Right, we do need to accumulate these somehow. Right, so in here we gotta add number to something. Right, so we should probably keep track of another variable that kind of accumulates the sum. Right, so in this case, I'm gonna declare another variable called total. Right, this variable is meant to accumulate all of those numbers together. Right, we can start total at 0, and inside of every iteration, we can accumulate it. Right, so this is saying, right, so this is saying within every iteration, we're going to update total. Right, we're going to set it equal to its current total plus the number that we're looking at. Right, so all these numbers will get added. Okay, there we go. So I'll press play. Okay, it didn't output anything, but it did loop. All right, let's go ahead and add a print statement. I'm going to add a print statement to sanity check these variables. Right, so this the one I'm just going to sanity check the total. Total is, let me use an F string here. Okay, there we go. Total is 188. I think that's right. If you add up all these numbers, it's 188. Okay. If we were to put this print statement inside of the for loop, right, let's see what's going to happen. Right, so I just indented it. I indented the print statement, meaning it now belongs inside of the loop body. Right, so it should print total a bunch of times now. Right, so here, let's see. So I'm going to press play. Okay, there we go. See how there's a bunch of print statements? Right, on the first iteration, total becomes 1, right, which makes sense because 0 plus 1 is 1. And then on the next iteration, it becomes 24, right, because 1 plus 23 is 24. Right, on the next iteration, it becomes 70 because 24 plus 46 gives us 70. And so people kind of seeing how loop algorithms is kind of, it's repeating computation to reach a singular value. Right, that's kind of what a reduction algorithm does. Okay, people cool with this so far? All right. This notebook does introduce something called a debugger. Right? We haven't really used the debugger yet. And you know what? In this class, I don't think our programs are complex enough to really use the debugger. A debugger is a way of kind of stepping through a program and sanity checking variables. The way that we've been debugging so far is just with plain print statements. Right? Like you can think of this print statement as a debugging statement, right? We're visualizing each step of the loop iteration in order to sanity check its current value. Right? This is one way of debugging, but as your programs get more complex, it might be necessary to use a debugger. And in this notebook, there is a bug button over here on the top right. I rarely use this just because I'm kind of testing frequently. I test very frequently to make sure that the program is fine every step of the way, right? But you can use this if you're not sure what's really going on. So I'm gonna press this debugger button. It's okay. There we go. I just pressed the debugger button, and now it gave us a tool on the right, and it also gave us some line numbers over here. Basically, these line numbers, we can click on a certain line and have it be a breakpoint. A breakpoint tells the debugger when to stop so you can press continue again. So if I were to put a debugging point right here, I mean a breakpoint, right? I'm gonna put a breakpoint over here in the total. This way, when we run the program, it'll stop at this line, and then we can keep stepping through it. Right, so here, let me press play somewhere. Where's the play button? See, press play. Okay, cool. I just pressed play, and the cell did not finish completing yet. Right? See this asterisk? It's not done completing. Right? Basically, these first two lines finished, right? And then we entered in the for loop, and we stop here. Right? This is the breakpoint. We stop at this highlighted line. So it's still running. We can use the debugger to visualize every variable in the program currently. So let me click on this over here on the top right, variables, right? The local variables. So there we go. Cool. So this is showing us every variable in our program, right? So for example, we have the variable total. Right? Total is currently at 0. Right? It's currently at 0 because this highlighted line didn't finish yet. Right? So that's why it's 0. And then number, right? This is a variable. It's a loop variable, right? Number is this variable here. Right? Number is currently 1, right? Which makes sense because on our first iteration, we're grabbing the first element. Right? Okay, cool. So let me step through again. There's a play button somewhere. Is it this one? I think I gotta press play here again. So press play here. This means to continue, right? Continue from the breakpoint. So I'm gonna press play one more time. Okay, there it is. I just pressed play. And let's see. Oh, it's still the same. I think I have to press a different button. Is it this one? Yeah, it's not this play button. Basically, this play button is restarting the cell from the top. I need to find a way to press continue. It might be this button here. Continue. Oh, here it is. Here's a continue button. So let me press this continue button, which means it should execute this highlighted line and keep going in the program. So let me press play here. Okay, there we go. I just pressed continue once. And let's trace through what happened. Basically, the highlighted line got completed once and it looped back around. Right? And we take a look at the variables here on the top right. We can see that the numbers got updated. Right? The total got updated to 1. And then our number got updated to 23. Right? So this is, once again, total is the variable that keeps track of our sum, and number is the loop variable. Right? We're looking at the next one. So let me press play again, right? Or continue, I mean. Right? Continue. And then there we go, right? It updated total to 24. And then now we're looking at the next number, 46. And we can keep pressing play. Right? Keep pressing continue. And then it should finish at some point. 188. Oh, you know what? It's restarting over and over again. Huh. Yeah, so once again, I rarely use the debugger. because in this class, our programs aren't too complex enough. But yeah, for some reason, this continue button keeps restarting the cell. Shouldn't do that. Maybe I need to add in another breakpoint somewhere. Yeah. Let me zoom out a bit. It's not that. Maybe it's next. Okay. I guess it was the next button. So yeah, anyways, if folks are wondering what happened, these buttons are slightly different. Earlier, I pressed the continue button, which restarts the cell at the end of the loop for some reason. So I ended up switching to this next button. Right, this next button allows us to kind of visualize things. Like, let me press next once. Okay, there we go. We initialize total of 0, and I can press next again, and there we go. We're there. And then total is 1, right? And then it prints it, loop back up, and keep pressing next. Right? See how it's executing line by line, and it's kind of showing us the value of each variable. And then finally, it should finish at 188. There we go. Yeah, we finally finished. Okay, so yeah, the debugger is good for kind of stepping through code. All right, I'm gonna disable it right now. So let me click this bug button again. Yeah, it's good for that. But a good start would just be to sanity check by printing values of variables. Right, this would be a good start. And once your programs get more complex, you can use the debugger button and kind of step through each line of code. Are people cool with this so far? Okay. All right. This is a loop algorithm that's generalized as a reduction algorithm, which takes a sequence of values and just collapses them down to a single value. And that's all we really did. Right? We collapsed this down to a value called a total. Let me just put in this here again. Oh, you know what? I don't have to really do this. I can just reuse this print statement, put it outside. Right? So we're taking a whole list, we're collapsing it down to a single value. That's a reduction algorithm. All right. Let's take this a step further and calculate the average. Right? The average is like the mean. Right? It's a statistics problem. Right? The average means we're adding up everything and then dividing it by the number of elements here. Right? So think of, maybe you could think of these as like a bunch of exam scores. Right? And if we were to calculate the average of the exam scores, right, we'd have to sum them all up. And then in the end, we'd have to divide them by the length of the list. Right? That would give us the average. So that's what this does right here. Right here, let me build up to it. Right? Like let's say we were to make a function called average. Right? Like let's say we were to have a function called average. Let me make a new cell. Right? Pretend that we had a exam scores. Right? I'm just gonna use a random scenario. Right? Let's say someone got like 100, someone got like a 80, someone got like a 90. Okay, so I'm just gonna keep it small for now. All right, so let's say we were to have a function called average, and we pass in the exam scores. And let's say we printed it out. Right? The goal is that, whoops. The goal is it should print out 90, right? Because 90 is the average. Right? Once again, this comes because 100 plus 80 plus 90, right? This gives us 270, right? And then 270 divided by 3 is 90. So let's write a function that does this for us, right? Because our list could be anything. Okay, let's write a function called average that iterates through a list. Right, so in this case, you can call it whatever you want. Right, I'm going to call it numbers. Right, you don't have to call it exam scores because when we call the average function, right, exam scores will be passed up and referred to as numbers. A very general list. All right, so what's the first thing we have to do? Right, well, we got to calculate the sum. Right, so we just did that. We declared a total, set it equal to 0, and then kind of accumulated it. So we can go ahead and accumulate it in a for loop, right? For number in numbers. Right, we're going to go ahead and accumulate it. Total is equal to total plus number. Right, people cool with this so far? So yeah, all this loop is doing right now is adding up every single number in the list that we passed in. All right, so here, let me do a sanity check. Right, before we divide by the length, let me just go ahead and return a number. Right, let me just return the total for now. Okay, there we go. This is just to sanity check things. Right, it's not the average yet. It's actually the sum. Right, so now if I run this playground cell down here, this testing cell, I mean, it prints out 270, right, which makes sense because when we sum up all the numbers, they are 270. Right, but that's not the average. Right? The average, we need to calculate that from the total divided by the amount of things in the list. Right? So we could say something like result is equal to the total divided by the length of the list. Right? Length of the list is numbers. And then now we can just return the result. Right? Result is the average. Okay, so let me load this function in and press play. There we go. See, now we got 90. That is the average of all of these. Okay, and just to reiterate, this function is general enough to work with any list of numbers, right? Like if I were to put in, like let's say someone got a 0, let's say someone got a 50, let's say someone got a 75.5, just some random numbers. This is a brand new list, right? It's gonna get sent up into this function. It's gonna refer to as numbers, and we're gonna recalculate a result. Right, so let's press play. Right, there we go. Right, the average here is 65.9. All right, people cool with this so far? This is a reduction algorithm. It's taking a sequence and collapsing them down to a single value. All right. Any questions about this so far? All right, let's see. So that's pretty much it for the lesson. There are other things here. We're gonna do this on Monday. Right, there's more stuff. Another algorithm is called filtering, where we pass a list in, and then it'll return another list, a filtered list, based off some criteria. And there's another algorithm called mapping, right, where you pass in a sequence, and it'll return another sequence of the same size, right, but the elements will be a little different. Okay, yeah, we'll do this on Monday, but I think folks should have enough to do at least the first 3 in the lab. All right, so let me switch to the lab. 17, lab 17. Okay, part 1, I think we have enough to do it. Let me skim through it real quick. Okay, yeah, we do have enough. We have enough to get like the first 4 done. So in part 1, we should be able to do number 1, compute the sum. Number 2, find the largest value. Number 3, find the smallest value. Just the opposite of the previous one. And then this one's a little different. boldface, this one is working with a list of strings instead of a list of numbers. So you can probably do this too. You're basically going to be doing string concatenation, or you're adding strings together. Okay, yeah, you should be able to do maybe 5 of them. But yeah, for now, let's see if we can get the first 2 done. I think folks might have a bit of trouble on number 2. It's that number 2 is asking you to find the largest value. Right? Largest value means what is the max? Right? So like imagine if we had a function here called largest element, right? Like let's say we had a function called largest element, and then we passed in some arbitrary list, right? In this case, oh, you know, here, let me rearrange this. Let me rearrange this. So let's say we passed it here. My list. And let's say we were to print it. Right, the goal of this function is it should do a reduction algorithm. Right? It's going to take a list and then return what's the largest element here. Right? So you're going to have to maybe make a function here called define largest element. Right? And it takes in some numbers. Right? I'm just gonna call this numbers. Right? Basically, your goal is to iterate through this sequence and find out what's the biggest number. Okay, so this is going to be a tiny bit tricky, but if you can do the largest value one, then you can probably do this smallest value one too. Okay, anyways, here, let me help folks get started on this, because there are some encoding here that we didn't really cover. So let's kind of talk about that. This first cell doesn't need to be here. Yeah, this first cell doesn't need to be here. If folks want to go ahead and delete this, feel free. So I'm going to delete this cell. Okay, number 1 is asking us to compute the sum. Right? We just did this a couple times in the lesson, so folks should be able to do this. If anything, there's some weird numbers here, like 0x12. What is this, right? Or 0b1101. This is just another way of representing a literal number. Right? So you don't really have to know too much about this. This is a hex number. Right? Hex number, and this was a binary number. Right? For folks who are familiar with binary, this 1101, this represents some number. Right? You don't really have to know this too much yet, but yeah, this number represents something. I'm just going to replace it with what it represents. Right? If you're curious, that this represents, let's see, 1 plus 4 plus 8. So it should be 13. Right? And you can verify this just with another cell if you want. So here, let me just make a playground cell just to visualize things. Right, so there we go, 0b1101. This is binary. Right, 1101. This should be 1 plus 4 plus 8. Yeah, this should be 13. Okay, yeah, this is 13. So yeah, you don't really have to know binary in this class, but you can replace this with the literal 13. Same thing. And then with this hexadecimal, right, 0x means that these next numbers are hexadecimal, which is a different numbering system. Right, this represents, let's see, it represents 16 plus 2. So this represents 18 in base 10. So let me verify that. 0x12 represents 18. Yeah. If you're curious about this, you can do some further research on it. Basically, there's a lot of ways on representing a number. Right? As humans, we represent numbers with base 10, meaning like we have 10 fingers. So we start over when we reach 10, right? Like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we loop around and then add another digit. But basically, hexadecimal works a little differently. There are 16 fingers in hexadecimal, so it would be 16 plus 2. All right. So I'm going to replace this with 18 because that's the base 10 representation. Okay, and what else? I'm going to replace these accordingly as well, because folks don't really have to know too much about character encoding. So this is the number 13. This is the number 18. Same here. 13, 18. Okay, there we go. I just replaced all of those. Okay, folks should have enough to get the first one done and the second one. So yeah, go ahead and give it a shot. We're going to revisit this again in like 15 minutes. So yeah, let's take a 15-minute intermission, and we're going to go over part 1. Okay. Yeah, feel free to call me over if there's anything weird happening. Once again, to reiterate, on part 1, you should be able to get number 1, 2, and 3 done. Number 4 is a different type of algorithm. This is a mapping algorithm. Right? We won't cover mapping until next week on Monday. So yeah, just do the reduction algorithms, 1, 2, and 3. All right, let's get back into this lab. Hopefully people had a chance to try this out. Number 1, we already did this in the previous lesson. But as for 2 and 3, find the maximum, find the minimum. Hopefully people give that a shot, because there are a few different approaches one can do. Let's see. So here, let's start off with the first one. Calculate the sum. Now, this one says write a for loop that computes the sum. Oh, it says prints the sum. It should have said compute. So let me just change it real quick. Yeah, it should have said computes the sum of all elements. So yeah, we already did this. Pretty much you want to write a loop that goes through that sequence. Right? So for a number in my list, we're going to sum up everything. So we got to keep track of a variable. Right? I'm going to set it equal to 0. Right? And we're going to accumulate that variable within every iteration. So total equals total plus number. And there we go. Right? That's the summation loop. And then outside of the loop, we can just print the total. There we go. Yeah, it should be 326.4. All right, people cool with this so far? Okay. Just in case some folks might have used a pre-built function, Python does have pre-built functions that already do this for us. Like for example, they have something called a sum. Right? They have a function called sum, which takes in a sequence, and you can just put in my list here to kind of verify it. So you can verify your answer by printing out this pre-built function. Right? Yeah. See, they're both printing 326.4. Right. So once again, if you use this function, the whole goal of this lab is really to practice loop algorithms. Right? So if you're using this pre-built function to do the work, it's not really the point of the lab. The point of the lab is to exercise how these functions work. Right? This sum function is really doing this, right? But with a lot more safety. Okay, so yeah, you can use that, but we want to do a for loop instead. Okay, so let me just do that. Total. Okay, let's go on to the next ones. Find the largest value. And once again, we have a list. Our goal is to reduce this list into the largest value. Right, there's a couple ways we can do this. right? I mean, one way we can do is we can iterate through each of them and kind of see which one beats the previous one, right? Maybe we could say, hey, is one larger than the current max? Well, it depends on what we initialize our current max to. Right? So if we were to initialize our current max to 0, then yeah, 1 would be the current max. Right? And then we can go to 2 and say, hey, is this bigger than the current max? Yes, it is. Right? So then our current max will become 2. And then we could look at this. Right? Is this greater than our current max? Yes. Right? And then so the current max would be 3.4. Right? We'll go on to the next one, and it'll update it. Right? 239 is greater than the current max. So this would be the current max. But then we move on to 43. Right? Is 43 greater than the current max? No, it's not. Right? The current max is 239. Right? And we can move on to 18. Is this greater? No, it's not. Right? So the current max remains 239. Right? We could go to 13 and keep going on. Right? And then our end result is return the current max. Okay, so that's one way we can do it. Right? We can initialize a current max equal to something, right? And then search for the current max. Right, so I'm going to put a to-do here. To-do find the max. And then at the end of it, we could return the current max. This is just one way. Right? This is saying initialize the current max equal to something. Right here, I'll initialize it to negative. I'll initialize it to 0 for now, actually. Right? This is actually not what we want to do yet, and we'll see why in just a bit. Right? Let's say we initialize our current max to 0, right? And we want to search through this list to see what beats it. Right? If any of those items beat it, then we can update the current max. Right? So that's what we could do. Right? Let's write a loop, right, for number in numbers. Now, once again, the singular and plural. Right? We could check that number and see if it beats it. Right? So we could represent that in a if statement. Right? If something, right, we want to write a condition that represents that that number beats the current max. So the condition here is if the number is greater than current max. Right? This is saying if we beat it. Right? And if we did beat it, we should update the current max. Right? So we could update the current max and set it equal to whatever number beat it, which is number right here. Okay. All right, so let's test this. Right, once again, this is a algorithm. I like to call it the high watermark algorithm. Right here, let me just test it real quick, and then I'll explain what high watermark means. Okay, so I'll press play on this. There it is. It's printing 239. Right, so that doesn't make sense. This is the largest number. So let's talk about what a high watermark algorithm is. You can think of this as like a beach with waves coming in. Right? Imagine a wave comes in and it makes the line in the sand. And another wave comes in. Right? If that wave is bigger, it's going to make a line in the sand that's higher than that previous one. Right? But then let's say another lower wave comes in. Right? That lower wave will come in. Right? It's not really going to make a bigger watermark. Right? Our previous high watermark will still be there. So yeah, you can imagine this as waves coming in, right? And then the max is where our watermark is. Right? In this case, current max represents our watermark. Okay, so let me do some debugging statements here. All right, once again, you can do the debugger here, but I'm going to stick with print statements so we can visualize what's kind of happening. All right, what's happening here? Let me put a print statement in here. All right, like let me just say found a bigger number. And then I'm just going to say, I'm just going to put this in an F string, number. Right, basically, this is a debugging statement that will tell us whenever we update the watermark. Okay, so let me just press play here, load the function in. Let me play here. Okay, there we go. So let's trace through this. Right, there are 4 print statements here. Okay, so we pass mylist into this function, all right, so we refer to as numbers. All right, our current max is initialized to 0, and then we start iterating through the list. Right, so our first element is 1, all right, 1 right here. Right? So is this number greater? Is it greater than the current max? Oh, yes, it is. Right, 1 is greater than 0, so we found a bigger number. Right, since we found a bigger number, we're going to update that watermark, right, the high watermark, to the number we're looking at. Okay, then we're going to move on to the next number. We're going to loop to the next number, number 2. Right, is 2 greater than the current max? Right, current max is currently at 1, by the way. Right, so 2 is greater than 1. So we found a bigger number, and that's 2 right here. Right, so loop again. This happens with 3.4. This happens with 239, but it doesn't happen with 43. Right, and that's because 43 is not greater than our current max. Our current max is 239. And this keeps going on, and then our current max remains at 239. All right. People cool with this so far? Okay. There is a flaw with this approach, though. Does anyone know the flaw with this approach? Well, this approach is assuming something about the list. Right? It's making a very large assumption. Here, what if I use a different list? I'm going to comment this list out and make a different one, and folks might be able to see what's going on. Okay, let's say we have another list. I want to set it equal to a bunch of negative numbers this time, like -5, -3, -20, -55. Okay, there we go. What should the max here be? What should the max here be? Our biggest number should be -3. Okay, but what is it going to print? So let me press play on this. It prints 0. All right, why is it printing 0? It should print -3. This is our biggest number. So what's the flaw with this, with our current implementation? Right, or more specifically, how can we fix this approach? So the flaw here, we're assuming that the list will only be positive, right? Because when we set the current and max equal to 0, we're saying that we're assuming that there's no numbers that's going to be passed in that's lower than 0. Right? So does that make sense? How we're assuming that everything's going to be positive, but when we passed in negative numbers, right? None of these numbers got a chance to beat the current max. Right? Like -5 doesn't beat this, right? -3 doesn't beat 0, right? None of them beat it. So current max never gets updated, but it should be updated. Right? I mean, you could fix this flaw by setting this max to a smaller number, right? Like you could say -1000. Right? You could set it equal to -1000, and it should work as intended. Right? So there we go. Right, so I just ran it. I initialized the current max to -1000, and people kind of seeing what's happening here. It's -5 does beat -1000, so we found a bigger number. And a -3, this does beat the bigger number, right? Because the current max gets set to -5, right? So then we update it, right? But then -20, it doesn't update it. Right here, let me just put another debugging statement so people are aware. So found a bigger number. Let me just do another print statement. current max is now. Okay, just a couple of debugging statements. I'll press play here. Let me run through here again. Okay, so once again, our current max gets initialized to negative 1000, right? Negative 5 does beat it, so our current max becomes negative 5. And we go to number 3, negative 3. This does beat it, so we update it to negative 3. But these next two elements, they don't beat the current max, so they don't get updated. Okay, so hopefully people kind of seeing how this max algorithm works. This is still flawed though, right? Like, what are we assuming? Well, we're assuming that the list will have numbers larger than negative 1000, right? So this is still flawed because if I were to pass in other numbers like negative 2000, negative 2500, negative 3000, I'll go negative 1500. Right, what should the largest element here be? Right, the largest element here is negative 1500, right? But it's going to print negative 1000, right? And negative 1000 doesn't even exist in this list. And so hopefully people are kind of seeing the flaw in this high watermark approach. Right? Basically, we have to initialize current max to something very, very small. Right? I mean, you could use something called negative infinity. Right? You could use something called a math.infinity. I think you have to import something for this. I think you have to import math, which will allow you to access a variable that represents negative infinity. Right, so you can set it to that, and it should work as intended now. Right, there we go. Yeah, now it finally prints out negative 1500. All right, people cool with this so far? So yeah, anyways, one approach is called the high watermark algorithm, which initializes a watermark to some small number, right? And then the loop would look for larger numbers. Right? If there's a larger number, it's going to update the current max. Okay, hopefully people are cool with this. This is an important algorithm because it's part of statistics, right? Sometimes we're analyzing data and maybe we want to find out what was the largest element in that data. We're going to see this next week, right? Next week, we're going to have some data analysis assignments. In particular, we're going to be analyzing Major League Baseball players and kind of printing out their stats. Okay, before I move on to this third one, actually, I'm not even going to do a third one, just because this is pretty much the same as the largest element. If folks can do this largest element, you should be able to do this smallest one as well. Right, you just got to flip a couple signs and then initialize the current minimum to something else. All right, so just real quick, this is still actually a little flawed. This approach is still flawed. It'll fail on the empty case. Like, let's say our list was empty. So let me just make a empty list. Right, so there we go. All right, what's the current max here? Right, it's going to print out negative infinity. This is not really a flaw, but it's saying that our largest element is negative infinity when there's nothing in here. So it's up to folks how you want to design. Pretty much you can do some protection, like saying if the list is empty, then you can have an error message or something. But yeah, for now, this high watermark algorithm would be sufficient. All right, people cool with this so far? All right. So once again, number 3, this is another reduction algorithm. It's the opposite of the largest element. Folks should be able to do this. Please try this out before next week. All right, next week on Monday, we're going to be doing more looping algorithms. And yeah, this would be a prerequisite. Okay, number 4, we don't know how to do this yet. This is a mapping algorithm. A mapping algorithm is right here. in the lesson, a mapping algorithm takes a sequence and then it returns a sequence of the same size. Right? We haven't really done this yet, but yeah, we'll touch this on Monday. Okay, so we're pretty much done with the first 3 parts of part 1 in Lab 17. Let's summarize what we did so far, and then we'll end today. In the beginning of class, we talked about while loops. Right, there was no associated labs with this while loops. Right, the important part of this class is writing for loop algorithms to go through a certain sequence. While loops are good too. Right? They're really good, especially if you're implementing things that can possibly be infinite. And then we moved on to a sneak peek on week 12. Right? Week 12, we're going to be doing some data analysis. Right? In particular, I'm going to release another assignment over the weekend. Right? It's pretty much going to ask you to write some loops to go through a large data set and then calculate some statistics from it. Right? Like who is the largest baseball player? Who is the smallest baseball player? It's pretty much going to do something like that. All right, so thank you all for coming. That's pretty much it for today. Have a great day, folks.